All right, superstars, welcome back for one more day of estimating square roots. And again, welcome Miss Fung's class for our virtual learning, trying to help you guys out as well. So, just like what we did the other day, we're going to start off by estimating the square roots to a decimal place. Then we're going to do just a little bit more calculations. Now, the calculations isn't the hard part. It's just kind of like, did you do that first part correctly? And then now can you add or subtract a number together? So let's see. Regardless of which method you did yesterday, we're going to go ahead and approximate the square root of 32 to be the following. We're going to go ahead and say that it is in between two perfect square roots. We're going to say that it is in between a 25, meaning the square root of 25 is 5, and the 36, or between the square root of 36, which is 6. Now we then said, okay, what's the middle point? The midpoint is going to be 5.5. So we add those together, cut it in half, 30.5. But this is really just confirming which side it's on. Is it on the low side or on the high side? Is it an lower 5, meaning like 5.1, 5.2, or is it an upper 5, like 5.7, 5.8? Based off of our thinking, we said, you know what? We can do method 1 or method 2. We're going to verify right now that it is an upper 5, and it's going to be approximately 5.6. If you were to do method 2, you would guess either 5.6 or 5.7 and multiply and find out that 5.7 is a little bit too big. 5.6 is about just right. So again, that part is a refresher from what we did yesterday. Again, I personally preferred method 2. Some of you might have preferred method 1. Method 2 is guessing and checking, meaning you guess your answer, multiply it back together, and see how close you get to 32. All right, now let's use that thinking to help us complete this problem here. So instead of adding 3 plus the square root of 11, I would like to find out what that decimal is so that I can add them together and then quickly divide by a 2. So if you notice, we're going to go ahead and take the square root of 11, which is going to be in between the square root of 9 and the square root of 16. We know that the square root of 11 is closer to the square root of 9, so it's going to be a lower, and we can confirm that by saying the midpoint is 3.5, which happens to be square root of 12.5. Because again, add the 9 and 16, you get 25. Half of 25 is 12.5. But which lower is it? Is it all the way down to 3.1 or is it 3.4? Again, regardless, you choose which method's best for you. I like method 2. So I would guess either 3.1, 3.2, 3.3, 3.4, multiply together to see how close I get. If you want to do method 1, then it's in between. So we're going to say that our approximation is going to be about 3.3. So I'm going to go ahead and say my new problem is now going to be 3 plus, and instead of the square root of 11, we're going to say 3.3. But remember, we're going to add before we divide. So add our numbers together really quick. 3 plus 3.3 is going to be a 6.3. Divide by 2. Again, if you can't divide it in your head, you'd go off to the side and divide it. So we're going to say about 3.2. Because again, if you'd like to, it's really going to be 3.15, but we're going to say, rounding to the tenths place, 3.2. Now, the little bit of difficulty because we're rounding and rounding again. If you remember from elementary school, you really just round at the very end, which is why this is an estimation, sometimes called approximation. We're really just doing the best that we can. Again, 3.15, it really becomes a 3.2, which is the nearest tenths place. But it's really just a repeat of what we did before of trying to find the square root of a non-perfect square root. Let's try another one. Now, this one actually has a little bit of strategy behind it. Do you notice how the 3 is in front of the square root of 11? Now, you can find the square root of 11, which we already know is 3.3 based off of our previous one. But we want to show you on this one here, instead of saying 3 multiplied by that 3.3, which is the approximation, is we can do our backwards thinking. And this is what we did last week. If I bring the 3 inside, remember it's a pair of 3s because we're dealing with square root, which really gives me a 2 subtract the square root of 99. Now, some of you can just look at that and know what the square root of 99 is because the square root of 99 is so close to the square root of 100. We know the square root of 100 is 10, so that means the square root of 99 is probably, what does your psychic powers tell you? Well, we know it's in between 9 and 10, right? But it's really close to a 10. So can we just say it's really close, so it's about 9.9. So a 2 subtract a 9.9 is a negative 7.9. We love it when it's that one and it's like super close. That's like one of the easiest square roots that's non-perfect to be able to find. But the whole goal of that was going backwards, like we tried teaching you just the other day. All right, this one right here is just helping us with our understanding of putting numbers in numerical order. Now, students sometimes struggle with this, really just putting the answer together. And we'll show you what that looks like in just a moment. So as you're writing it down, you should know that the 9 is really from the square root of 81. Because the square root of 81 is 9. In other words, I'm trying to get them all into the same form to be able to compare them to help me order them from least to greatest. Just like we said decimals, you want decimals in the same form so that you can compare them. So let's try the same thing with our roots. Instead of 11, we're going to say that the 11, going backwards essentially, is the square root of 121. Now that all of them are the same form, we can put them in order from least to greatest. But the key thing is making sure that your answer is using the numbers from the original problem. Meaning I notice that the smallest or the least is the square root of 81. But the square root of 81 is not my actual number, so I cannot put the square root of 81 as my answer. I'm going to start with a 9. Then I continue from least to greatest. I'm going to say the square root of 84. Well, the square root of 84 was my original number, so I'm going to put the square root of 84. Notice how we did not take the harder method and try and change the square root of 84 into a decimal. That would just take us a little bit more time than we'd want. Then I've got 2 more. The square root of 99 is next, which is my original number. And then finally, the square root of 121 is last, but I'm really going to put the number 11. So the key is to use your correct original numbers. We did the same thing with Math 7 students in trying to change fractions to decimals and put them in the correct order. Maybe even percents, put them in the correct order. But you got to use your original numbers for your answer. All right, let's try this one as well. Again, a little bit easier to go backwards, meaning let's take our integers or decimals for 1.5 and put them into square roots. So we know that a 5 is really found from the square root of 25. Because 5 squared is 25. Square root of 25 is 5. My 1.5 going backwards, imagine without the decimal. 15 squared, what's 15 squared? This is why we asked you to memorize them. 15 squared is 225, so this would really be the square root of 2.25. Now that they're all in the same form, we can go ahead and put them in order from least to greatest, but we're going to use our original numbers for our answer. The square root of 2.25 is the smallest or the least, so let's put 1.5 first. Then we go to the square root of 5. Now be careful, don't say 3. Even though we know the square root of 9 is 3, we're just using our original numbers. And then finally, don't say square root of 25 because our original number is 5. Just trying to help you get a little bit quicker with your squares, square roots on this process, and then putting them in order from least to greatest. All right, let's jump into a little bit of homework help. So our amazing subs, if you can go ahead and pause the video, pass all the worksheets out, and then we'll come back together for a few problems to help each other out. All right, welcome back. We only have a few problems there at the beginning. I'm actually going to ask us to try number 3 together. Now, it's not because the square root of 10 is really easy. It's because I want to make sure that we are comfortable with our fractions to decimal conversions. All right, where'd my writing tablet go? There it is, right in front of my eyes. It's been a long day, guys. Let's see here. Square root of 10, our approximation. Now, refreshing your memory again. We know that the square root of 10 is in between the square root of 9. Come on, Mario. Mr. Mario. Square root of 9, which is a 3. And this has got to be a 4, which is the square root of 16. We're going to say 3.5 is in the middle. We add the 9 and the 16 to get a 25. So again, it's just kind of a quick refresher. Square root of 25 cut in half, though, is 12.5 because we're talking about the middle. Square root of 10 is somewhere over here, which definitely tells us it's not an upper, it's a lower. Now, is it in the middle of that at 3.25? Really, again, I'm going to try it method 1. So I'm going to say 3.1, 3.2, 3.3, 3.4. Now, I do remember that the square root of 11 we said was 3.3, but if you forgot that, let's just try 3.2. Again, this is my preferred method. So 2 times 2 is 4. Zoom in for my vision challenge friends. 2 times 3 is 6. Placeholder. 3 times 2 is 6. 3 times 3 is 9. Let's add it up and see how close we get. We've got a 4, 12, 1. Oh, look, it's a little too big. The 10.24. So we're going to go ahead and say 3.1 is going to be our good approximation there. Because again, the 3.2, when we multiply, 2 times 2 is 4, 6. I'm just double checking because I made an error on that other video and you guys probably laughed. Oh. Yeah, so we're going to say 3.1 is probably good there. So we're going to go ahead and say that the square root of 10 is approximately 3.1 plus, let me change colors to have it stand out. And 1/5 is really going to be 0. And if you don't remember the decimal form of that fraction, you could always go and do your division. So that was the main reason I chose this one here. 5 and 1, no. 5 and 10, yes. So 0.2. And if we add it up together, we're going to say that this is approximately 3.3. So again, so it's just a small continuation from what we did on the previous lesson or previous day. All right, let's go ahead and try this one real quick. Number 7, going backwards again to help us put them in order. We're going to go ahead and say that 7 is really the square root of 49, and that 5 is the square root of 25. Putting them order from least to greatest, square root of 25 is the least, so we're going to say 5, comma. Then we got the square root of 44. Then we have the square root of 49, which is really a 7. And then finally, we have the square root of 50, helping us practice our squares, square roots, quick knowledge there. All right, so let's see. That was directly from the notes. All right, being able to compare our information is going to be super helpful. Now, remember on this one right here, we said maybe you want to go backwards. We know that 2 pi, well, 2 times 3.14. So that's really going to be a 6.28. And then for this one, instead of saying 3 times the square root of 3, I can say, bringing this inside, got a pair of 3's, and then the 3 from the left over, which really gives me the square root of 27. Now, I don't know what the square root of 27 is, But as soon as I figure it out, then I'll be able to compare. So bring it over here to the side. Square root of 27 is definitely going to be in between the square root of 25 and the square root of 36. Well, I know right away that the square root of 27 is really close to the square root of 25. So maybe without even having to do full information, I know it's going to be a 5 point with a low number, maybe a 5.1. Even if I thought it was a 5.2, I think I can clearly see that this is going to be a less than. So on number 9, you're going to go ahead and figure out what the square root of 11 is. Maybe look at your notes. Do a little bit of division, and then compare the two. This one right here, a little bit more basic without having to do the approximation. This one right here, well, I think this is a good one. Let's do this one real quick. I know that 9 divided by 2 is 4.5. But I don't know the square root of 17 off the top of my head. So let's go ahead and find it here. I do know that the square root of 17 is in between the square root of 16 and the square root of 25. Now we know 4.5 is directly in the middle. Is the 17 directly in the middle, which means they'd be equal to each other? Or is the 17 closer to the 25, which means square root of 17 would be greater? No, it's definitely on the smaller side. So maybe like a 4 point, maybe a 1, which would allow us again to do a less than symbol. So sometimes on the comparison, you may not be able to get it or have to get it as accurate as it needs to be, but we're doing our best. All right, on the back side, a little bit of more ordering like we talked about before. We've got substitution, elimination method. Is it true or false, meaning is it a point on the solution to the system? We've got a quick word problem. Let's do the word problem real quick to finish us up. It says a fruit stand sells fruit baskets at the farmer's market. A fruit basket with 5 apples and 4 oranges cost $10. Now, I don't really like the O for oranges, so maybe I'm going to say R for oranges. So we're going to say 5A plus 4 oranges is $10. Now the fruit basket has 5 apples. Hey, look at that's helpful. And 5 oranges is $11. So if you notice, the apples are already the same digit, so let's get the opposite sign. So I'm just going to go ahead and suggest maybe if we multiply this bottom one by -1. You could have also multiplied the top one by -1 if you wanted to instead, which gives me 5A plus 4R equals 10, can stay the same. And then I have a -5A, a -5R equals -11. So the apples eliminate. The oranges is -1R is equal to -1. So if I divide by -1, then that means an orange is $1. So what is the cost of an apple going to be? Now remember, both equations are pretty much the same thing. I'm going to go ahead and take the top one there. I'm going to say 5A plus 4, well, R is 1, equals 10. So it means 5A plus 4 equals 10. One more time with the lights, come on. All right, almost done. Trying to find the cost of an apple. Subtract 4. divide by 5. So the apple is going to be a little bit more than $1. If you need to do your division, that would look like this, a 6 divided by a 5, which means we need a decimal. 5 and 6 is going to be a 1. 5 and 100 is going to be a 20. So it means an apple is going to be $1.20. An orange is going to be $1. My grandma, when she was alive, always used to say silly things like Washington and ornery. All right, superstars, please do your best and bring back any questions that you need.